get going here.
Okay.
All right, so let's just do a couple of quick problems here. Let's say something like -7 plus 5 minus 4 plus 3. Why don't you give that a try and see if you can correctly work that out from last time.
Okay. -3.
Your answer is -3. So the first two is -2 minus 4 plus 3. This becomes -6 plus 3. It is absolutely -3. Good, really good. So this idea of when you add and subtract, you do it left to right.
Mm-hmm.
The same thing applies to multiplication and division. You do
Okay.
that left to right. Okay, so
Yeah.
I'll give you, these are a little harder to come up with if the numbers get too big. But if I have 9 divided by 3 times 2 divided by 6, you work it left to right
Yeah.
like that. Okay, so why don't you give this one a try and see if you have any questions or start looking for some new problems.
Okay. Zero.
Okay, let's take a look here. 9 divided by 3 is? What is 9 divided by 3?
Oh, sorry. 3.
3. Okay, times 2.
Yes.
So next you have to do this. 3 times 2 is
6.
divided by 6. So
Yeah.
division is a sharing problem. Okay,
Okay.
division is sharing. If you have 6 things and 6 friends, each friend, they don't get 0, they get how many?
Oh, I thought, it's 6 divided by 1 would be 0, right?
No. 6 divided
No?
by itself is 1. It's a sharing. Like you have 6 pieces of candy and 6 friends. Each friend gets a piece of candy.
Okay. Sorry. I guess I learned that wrong or something.
That's okay. We have time this summer to clear some of this now. 6 divided by 1 is 6. Now, it's the same thing. You have 6 things to share, 6 pieces of candy and only 1 friend to share it with. Well, they get all 6 of them.
Okay.
Right? Or 6 people, 6 slices of pizza. Everyone gets a slice of pizza.
Yes.
All right, let's try another one here. Let's go 12 times 3 divided by 9 divided by 2.
Okay. I'm having trouble remembering what 36 divided by 9 is.
Okay, so let me do this. I've got a reference sheet on my website. You can go to any sort of multiplication, division thing.
Okay.
It's not a big deal. You probably you haven't done it in a while. But
Yeah.
what I'm going to recommend is that you spend some time looking at ones. Let me see if I can get that up real quick here. All right, there we go. Copy link. All right, so I'm dropping it in the chat. Also snip in a picture of it, but you're going to want to print this out or have mom and dad get something like this to print out. You really
Okay.
want to have your multiplication division tables available to you at all
Okay.
times.
Yeah. Okay.
So let me nip it in as well. The way division work is you have to find the number in the table. If you're doing 36 divided by 9, you go to like the 9 row and you look for the 36. and then you go up to the
Yeah.
4.
Okay.
I'm happy to snip this in each time, but it's a little bit more convenient to have it printed out if you can.
Okay.
But yeah, keep working on this. Let me know what you come up with.
Okay. Okay, I got 2.
All right, so 36 divided by 9 divided by 2. 4 divided by 2 is 2, like that. All right, so now let's go again here. Let's go 10 times 10 divided by 5 times 2 divided by 8.
Okay. Five.
You said 5?
Yeah.
It sounds correct. 100 divided by 5, so which is 20 times 2 divided by 8. 40 divided by 8 is 5. Like that. All right.
Mm-hmm.
Any questions on that?
No.
Okay, so a couple of things, couple of rules, kind of like when the adding and subtracting, the rules for multiplication and division. So if you take a positive number and multiply by a positive number, you get a positive number.
Yes.
If you take a negative times a negative, you get a positive number. So if they're same sign, it's always positive.
Yeah.
And this applies to both multiplication and division. We'll talk about division in a moment. Now, if they're opposite in sign, a negative times a positive is a negative,
Yes.
and a positive times a negative is a negative.
Yeah.
So when they are opposite sign, it
It's
becomes
a negative.
the negative. Okay. Now, where you can run into issues here is like, well, what if you have more than 3? So what if you have -3 times 4 times -1 times -2?
Okay.
So the best way to do this is just go piece by piece. So -3 times 4 would be -12. Okay. Times -1 times -2. What is -12 times -1?
Positive 12.
So 12 times -2 becomes -24.
Yeah.
All right.
Okay.
So there is some rules here, but that's good. So let's talk about division.
Okay.
Kind of the same situation. If you have a positive divided by a positive, it becomes positive.
Okay.
You have a negative divided by a negative, it becomes positive.
Okay.
So it's the same rule. Same sign becomes positive, same sign becomes positive.
Yes.
All right. Now positive divided by a negative becomes a negative.
Mm-hmm.
Negative divided by a positive becomes a negative.
Negative.
Okay. Now related to this, like let's say I give you a number like this. Let's say it's like 4 over -2.
Yeah.
It is -2.
Okay.
If it's -8 over 4, that's also -2.
Okay.
All right. Okay, so let's take a look at some new problems here. Actually, let me might as well do it this way. So let's go -8 times 3 divided by 2 divided by -4 times 3 divided by 2.
Okay.
So I want you to try working this out for me, please. Work out the top, then work out the bottom, and then divide.
Okay. Mm,
Let me know if you have any questions also.
Okay. Do we? Okay, never mind. Never mind.
I'm sorry, yeah, is that your final answer or you just start asking?
Oh no, I was just gonna ask a question, but then
Yeah, go
I
ahead.
don't need to anymore.
All right.
I just need 1 second. I'm almost done. Two.
Answers too. Good. All right. So now we're gonna do some synthesis here. Sure. We're gonna do some combinations. So I'm gonna give you problems that have both multiplication and division, and then addition and subtraction.
Okay.
What do you do first, though?
Multiplication and division.
Right. So if I give you a problem like this, 6 minus 3 times 2 plus 1, what do you do first?
3 times 2.
3 times 2. So you kind of want to like show that you're doing it first by not doing anything else.
Okay.
Then you have to reset. You have to say, okay, I've got subtraction and addition. Well, when there's addition and subtraction only, you just do it left to right.
Yes.
So what does this become?
1 plus 1, 2. Oh, 1. 1. It would
This
be 1.
becomes 1. 6 minus 6 is 0, plus 1 is 1.
Yeah.
Right. So let's look at another example here. Let's say it's 4 plus 12 divided by 6 minus 8. What do we do first in this problem?
12 divided by 6.
Okay, what does that become?
2.
2. So 4 plus 2 minus 8.
8. 6 minus 8, and then 2. 3,
4 plus 2 is, what is that?
6.
Minus 8.
Yeah.
What does that become?
2.
It's
Negative.
not 2. Negative 2.
Negative 2.
Yes. Yeah. Big difference.
Yeah.
Big difference. Yeah. All right. So here's one for you to try on your own. take a look at this and let me know what you come up with.
Okay. Nine.
Okay. Let's take a look here. What is 14 divided by 7?
7. I mean,
Or 14 divided by 2 is 7. Yeah,
7.
-1 plus 3. 7 minus 1
6.
plus 3 is
9.
9. Good. Really good. Okay. So let's look at another problem here. Sometimes, you'll get more than one multiplication and division. And the problem is, you have to make sure you see that, like there's addition, division, and multiplication here.
Yeah.
So you ignore the addition and you just focus on the division and the multiplication. So which do you
Yeah.
do first, the division or the multiplication?
15 divided by 5.
Yes. So go ahead and do that.
Okay.
That's 3. And I recommend just rewriting it. Really,
Yes.
there's no reason not to just keep doing that. So
Okay.
now do you add or multiply?
You multiply.
Right. So you want to do all the multiplication division, then deal with the additions and subtractions.
Okay. So 39.
Okay.
And then 9 plus 39 would be 138.
You're adding. Yeah, 48.
Yeah.
9 plus 39 is 48. Good.
Oh, yeah. That's right. I multiplied.
All right. Let me know when you're ready and we'll do a couple more here.
I'm ready.
All right. So here's a new one for you to try. So see how much you can work out on your own here, and we'll
58.
okay. How did you come up with that? Tell me what you did.
So first I did 12 divided by 3, which is 4. And then I did 4 times 12 plus 10. So I did 4 times 12, which was
Okay.
48. And then I did that plus 10, and I got 58.
Really good. All right. So you're doing great. Let me give you just a few more here to look at. You do need a bit more practice. We'll see if we can here's a good one actually. See where you're at. So here's a new problem.
Okay.
Definitely welcome to ask me questions, but see how far you can get on that.
Okay. I got 34.
So take a look here. This is 6 plus 14 times 2 is 28, which is 34. Very good. All right, so you're doing great. I'm gonna just keep increasing the difficulty here. We're getting really close to kind of the ones that they have the full on ones here.
Okay.
You're welcome to use. Do you have a calculator handy?
Yes, I do. I can go grab it.
Okay. No, we're basically at it. We're gonna be switching over. Let me give you one that I don't think you need one for.
Okay.
All right, so we'll do one more here and then we're gonna switch over to your sister here.
Okay.
Let's ignore this last part. Sorry, that's gonna be too much.
Okay. 10.
So tell me what you did first.
So first I did 5 times 4, which was, oh, give me 1 second. Can I redo it
Sure.
really quickly?
Of
Okay.
course, yeah.
40. Okay, there you go. 46 is what I got. Nope.
Try again.
Okay, I'm sorry. I
You-
totally
it's
thought
okay.
that was another number. Okay.
2 minus 1 is?
1.
Right, because you're just adding and subtracting, so you do that left
Yeah.
to right.
Yeah.
It
So,
becomes
and then
21.
5 times 4 is 20, and then 2 minus 1 plus that. And then, 21.
21, good. All right, so we're gonna stop here if you want to let your sister know I'm ready for her.
Okay.
And thank you so much. We'll get scheduled for next week.
Okay. Hello,
Hey, is this Julia or Victoria? I'm sorry.
Victoria. It's okay.
Victoria, all right. How are you doing today?
Good. How are you?
Good. So last time we worked on divisibility rules. You remember us
Yeah.
doing that? We're simplifying fractions and using the divisibility rules.
Mhm.
Excellent. Okay. So one of the reasons we're doing that is to simplify fractions, and we're going to do some other things. So let me give you a problem here to start out, and see. Why don't you see if you can simplify this using some of the rules we were using last time,
Okay.
and then we'll talk about where to go from here.
Okay, so for the first one, I got 16 over 20, and then I'll keep.
Yeah, keep going.
I got 4 over 5.
It is 4/5. Good. All right, really good. Okay. So you've got a pretty good understanding of this. So we're gonna learn something new today. We're gonna do what's called a prime factorization.
Okay.
And it's based on the divisibility rules 2, 3, 5, 7, 11, 13, and so on. We probably won't get that high, but we'll talk about it now. So we're going to build what's called a factor ladder. Have you heard of that before?
No.
Okay. So I'm going to pick a number like 8.
Okay.
I'm going to draw this little sort of half box around it. Now you start with 2. Is 8 divisible by 2?
Yes.
Okay. And what is 8 divided by 2?
4.
4. So the 4 goes underneath, and then you draw another kind of box here, and then you
Okay.
try the number again. Does 2 go into 4?
Yes.
Okay. See how it's kind of similar to what we've been doing? And then you put a 2 there because 4 divided by 2 is 2. And then you try again and get 1.
1.
So here's how you know when you're done. You're done when you get a 1 here.
Okay.
Okay. Now, the prime factorization are these numbers on the outside of the ladder. Like this is meant to look like a ladder over here. I don't know if it does or not, but that's what it
Yeah,
is.
it does.
So the prime factorization is 2 times 2 times 2.
Okay.
Okay, so let's look at another one here. Let's look at a factor ladder for like another number here. Let's pick a bigger number. Let's pick 18.
Okay.
Okay, so you start with 2. Does 2 go into 18?
Yep.
It does.
9.
9. Now, does 2 go into 9?
No.
So what's the next number you try?
3.
Does 3 go into 9?
Yes.
9 divided by 3 is 3. And then you put a 3 on the outside and you get a 1 here.
Oh, this is cool.
So this becomes 2 times 3 times 3.
Oh, wait, we've done this before, except we call it a factor tree.
Okay, that's what I wanted to know because sometimes it's
Mhm.
called a factor tree, but at
Yeah.
the level
we
you're
don't-
at, sometimes they use ladder. Now, if you
Yeah, we
want to
don't
make
like.
if you want to make
factor.
a tree, you
Mhm.
put the smaller number on the left, 2 and 9, 3 and 3, like that.
Yeah.
Okay, so it sounds like you've got this down. So why don't you do this? Why don't you give me the prime factorization for 40?
So would it be 2 times 2 times 2 times 5?
Like that?
Yeah.
So what's nice is you can check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is
40.
40. Good. Excellent. Okay. So we use the factor tree to determine a lot of things. Okay.
Mhm.
One of them is called the LCD.
Okay.
I'm sorry. Sorry. No. Let me
It's okay.
backtrack. We're gonna. Whoa. So we're gonna look at two numbers. Let's do 12 and well, we just did 20. Let's do 8, 12 and 18. I want you to find the factor tree for each of these for me, please.
Okay. Which one do you want me to do first?
Either one,
Okay,
your choice.
So would it be 2 times 3 times 3?
For which one?
For 18, sorry.
Okay, that works.
And then for 12, would it be 2 times 2 times 3?
Yes. Okay, now I'm gonna ask you some questions. What is common in both? What do both of them have?
2s and 3s.
How many twos though?
1,
And how many threes?
1.
Okay, so what they both have, and sometimes the way you do this is you circle it. You say they both have a 2 and they both have a 3.
Mhm.
Okay. What is 2 times 3? What does that equal?
6.
6. Okay, so this is called the greatest common factor.
Okay.
So whatever is common between them gives you the greatest common factor.
Oh, okay.
Now there's a bunch of other things that we're going to maybe talk about, but we'll just start with this one.
Okay.
So you have to build the factor tree then you have to figure out what's common between them. Now, if they had both had more than 1 2, you would have to include more than 1 2. If they had more than 1 3, and so on like that. Okay.
Okay.
So let's try another one here.
Okay.
Let's try 20 and 36. So I want you to build a factor tree for these two numbers, please.
Okay. Okay, so for 20, I got 2 times 2 times 5. And for 36, I got 3 times 3 times 2 times 2.
So the important thing here is, and I don't know if you built your factor tree this way, is you start with 2 times 18.
Oh, I started with 3.
You have to you really want to start with the smallest number.
Oh, okay. Okay, let me redo it.
Now you're going to get the same thing. What I'm trying to say is that the order matters because you want to see the similarities. And it's easier if it's, for example, these are in ascending order. This is an ascending order. And that's important to do.
Okay.
So what you had was right. You said 3 times 3 times 2 times 2. That's right, but it's going to be easier to figure out your greatest common factor doing it that way. So what is the greatest common factor?
Hold on.
What do they both have?
2 times. So
Okay, so what would that be?
2 times 2 times 2. So 16.
No, so you grab, it's like you grab, okay, that's a 2,
Yeah.
and then you grab there's another 2 that's the same. So you just
Oh,
grab them, whatever is the same, you grab there.
so 4. I thought you had to add all the 2s.
No, it's like if they both have it, you say we both have one.
Oh, okay. Oh my. Okay. So 4.
Yes, very good. Let's try another one here. Let's try let's go 28 and 42.
Okay. So would it be 2 times 2 times 3?
Give me the final number. What's the final number?
Okay. Is it 12?
So you're saying 12 goes into both of these numbers.
No. Hold on.
Okay, so try that again. This one was a little more difficult, but I mean, you've been doing such a good job. Make sure you have the correct factor tree for 28 and for 42. And I'd like you to give me the factor trees for both those.
Oh, I see where I went. Okay. Oh, yeah. Okay. Oh, okay. So So
What is your factor ladder for 28?
2 times 14 times, and then circle the 2, and then the 14 would be 2
Yeah, okay,
times.
okay, so, okay, all right, so yeah, there's a problem there. So for 28, yeah, it's 2 times 14, but there's 2 go into 14?
2 times 7.
Yes.
Okay,
So that it's 2 times 2 times 7.
that's what I
Now do the
put.
same thing for 42.
Okay. For 42, I got 2 times 3 times 7.
Say that again.
2
2
times
times.
3 times 7.
Yes, very good. Okay, now what is the greatest
2 times
common factor between them?
14.
14, yes. And what you'll notice is that 14 goes into both 28 and 42. Really
Yeah.
good. All right, so let's try another one here. Let's go 16, and then let's do 80. 16 and 80.
Okay. So for 16, I got 2 times 2 times 2 times 2.
It's
And
good.
for 80, I got 2 times 2 times 2 times 2 times 5.
Okay, so give me the greatest common factor.
Is it 4?
So you said all the right things. We're having some sort of a disconnect. We got to figure this out here because this is correct. Now, what is the same in both? Do they both have a 2?
Yeah.
They both have a 2. So you start by writing a 2. Do they both have another 2?
Yep.
So you write another 2. Do they both have another 2?
Oh, yeah.
Now I'm crossing them out this time. Maybe that's helpful.
Yeah. So is it 16?
Yes. Let's try another one here. Let's go 30 and 40.
Okay. Okay. Oops. Is the greatest common factor 10? I can't hear you.
Thank you. Thank you. Sorry,
Okay.
you were correct on that one. Yeah, sometimes I do mute myself to drink some water or something that I forget to unmute.
Sorry.
No, always tell me if it looks like I'm talking, I wouldn't know. Because I can only hear myself. Uh, now, sometimes you get 3 numbers, but it's the same process. So for 12, 12 is 2 times 2 times 3. 8 is 2 times 2 times 2. 20 is 2 times 2 times 2 times 5. What is the same? It has to be the same in all of them. What's the same in all of them?
The 2s.
The 2. So that first 2 is the same in all of them. And then
Okay.
that second 2 is the same in all of them. So what is the
Okay.
greatest common factor?
4.
All right. So let's have you try one here. Let's have you try 9, 12, and let's go 18. I want you to find the greatest common factor between those three, please.
Would it be 3 times 3 is 9?
For 9, yes. How about for 12?
For 12, 2 times 2 times 3.
Okay.
And then for 18, 2 times 3 times 3.
2 times 2 times 3.
I said 2 times 3 times 3.
Okay. Yeah, I misheard there. All right. Now, what is the same in all of them, if anything?
The 3s. 2.
So give me the GCF. What is the GCF?
3 times 3. 9.
Okay, but there's only 1 3 here, or there's 2 3s here, and there's 1 here.
Oh,
So it has to have. There's only 1 3 that's common in all of them.
I thought, oh. Oh. Oh, yeah, okay. So
All right.
3.
So here's what I'm gonna do here. I'm gonna put in the notes here a couple of problems for you to try for homework if you want. It'll also help me to know where we should pick up next time. But we are going to stop here for today. So good job.
Okay.
I
Thank
will,
you.
we're figuring out schedule with mom, but we'll get that going for next week. Probably will be Monday, Wednesday, Friday, 10 or 11. We'll get that dialed in. But that is
Okay.
it. I do got to run. Thank you so much, and
Okay.
I will see you next time.
You're welcome.